What I'm going to talk to you about today is biofilm risks for flexible endoscope decontamination. This talk has done its rounds, so for anyone who's seen it before, sorry, but you know, there's still people who need to see it. A little bit about me. I am the decontamination lead for Manchester University NHS Foundation Trust. I'm also the Director of Communications for the Institute of Decontamination Sciences and the Chairman of the Midlands branch for the same institute. I've been in the industry around about 16 years now. I know that says 15. And within endoscopes, very, very early on, around about 2008, 2009, we were one of the first trusts in the UK to centralise endoscope decontamination and have those processes under our 13485 and MDD umbrella. Okay, today the presentation will focus on the current process assurance tests for endoscope decontamination, the potential for biofilm accumulation and associated challenges, and we'll discuss whether flexible endoscopes should be categorised by the risk factor with additional process steps. So for that, we're going to look at process assurance tests, biofilm, and low or high risk processes. So the first one is the endoscope decontamination assurance test. We do a lot of things around endoscopy. We're looking at the machines. We do a lot of tests on the machines and the environment. First thing is the ARE validations. So again, if there's any AEs in the room, I'm not listing every single test. I'm just generalizing. Okay, so we're just going to do an overview of some of the things we look at. So we obviously have the machine validations, dailies, weeklies, quarterlies, annuals. We do process challenge devices, clean efficacy tests, automatic process control tests, and what about flushing devices? So we're looking at machines in that process. Anyone testing their flushing devices? One person over there. Okay, it is on the JAG IHEAM audit tool, section 8.16, and it asks if we're testing the water quality, but it suggests TVCs. Anyone think that's a bit of an odd one? This is a bone of contention. I could probably split the AEs in the room with this one of who says we should be doing TVC on potable water and who says we shouldn't. But there's no actual standard for it, but it's just a suggestion. Look at the environment. We do settle plates, air and pressure, air monitoring and pressure, oh, bloody hell, room pressure and air changes. We look at the water as well, measuring conductivity for obvious reasons, total organic carbons, mycobacterium, and TVC. Again, TVC keeps cropping up, okay? But what about the endoscopes? Residual protein, yeah? Everyone, any endoscope people in the room? Yeah, we're doing that one. Endoscope lumen sample. How many people are doing that test? You're sampling the actual scope's lumens of what's inside. No hands? It is actually mentioned in the HTM to do it, but there's a bit of a get out with the HTM, which is a bit of an odd one, saying you don't have to do it. When we look at BSEN 16442, which is the standard for dry storage cabinets, that recommends, it's strongly recommended, that the microbiological quality of the endoscope intended to be stored in the cabinet is tested. So that would be a suitable test to comply with that. But what about biofilm? Anyone? If we're not doing the lumen test, we're not going to be testing for biofilm, are we? So let's look at what we do test for and total viability count. Is it total viability count? This is the big question with it. It's actually not. It doesn't detect all organisms. So that's the first limitation with it. It won't pick up Legionella. TVC tests are conducted at 30 degrees, but there's a lot of organisms that will populate and grow outside that range, or actually thrive outside that range. And obviously pathogens, it's optimum for them to be around about 37 body temperature. So is it relevant? And things you can discuss with your test lab about the relevance of your TVC. How often do you get a TVC failure? Anyone? Rarely. So there's a number of reasons. I'm always skeptical of that. If I see constant zeros on TVCs, I wonder, none of our waters. And there's a lot of difference between the labs of what type of agar plates they'll use. Generally, you'll see an R2A agar or a tryptic soy TS agar. That's what's recommended in the A. The problem is, with the TVCs, we're all focused on water, and within water, we're all focused on Pseudomonas. But there's lots of other organisms that causes issues within endoscopy. Sample time is important with TVCs. We need to get it to the lab within 24 hours because a lot of organisms can actually die off in RO water as it's not ideal for their sort of continued life. So it's not a real life picture. Type of CFU, I would argue this is more relevant than the arbitrary numbers. So what we have in Europe is they allowed a total count to 20 CFUs. We have 10 in the UK. But again, is the count as important as what it actually is in there? And at the moment, what we've been doing is we've been culturing or doing a mouldy toff on every single, even if we get 1, 2, even if it's below 10, we mouldy toff it. And we're actually finding we're taking action and restricting the use of the washers and the water system based on lower scores than 10 because we've got pathogens in the water. And this is what a lot of people are not looking at. We get a score, we get 10, we don't know what it is, but as long as it's below 10, we carry on using scopes. Oxidase positive, this is one thing that some places look at, and previously I used to just concern myself with oxidase positive because that's what Pseudomonas is. But we need to concern ourselves with the oxidase negative as well. The oxidase negative organisms infection control groups. So your E. coli, your Klebsiella, your pneumonia, your CPE strains, they're all oxidase negative, and we're not even looking at them on TVCs. But when we sit down with the infection control committees, it's the main focus for those areas. So we've got this area that's really focused on it with the patients, scopes that are used within the hospital, but we're only looking at Pseudomonas in the water. We need to have a broader spectrum, broader approach. So these are all just things to consider and talk to your lab. Problem with these CPEs is what's commonly associated with duodenoscope-associated infections. So this is one of the things that we need to be looking at, particularly with duodenoscopes. So, do you know the type of agar you use? Tryptic soy agar, R2A agar, etc. That's generally what they'll be using in your test lab. But these are designed to isolate oxidase-positive Pseudomonas isolates. We're all concerned about one type, one worrying bacteria which is in the water. They don't support the enhanced or easy isolation of other oxidase-negative, multi-drug resistant healthcare pathogens. And that's why we need to be looking at different types of agar to use within the labs. In your diagnostic labs, where they do the urine samples and things like that within the hospitals, they'll be using chrome agars. Chrome agars are very, very good because they give you a broad spectrum of organisms, and they give you easy identification as well, because the way they work, they give you, like, it comes up as each type of species will come up as a different colour. Now, if you speak to your diagnostic microbiologists within your hospitals, they'll know all about chrome agars and they'll tell you the benefits of using them. But within the standards, within the HTMs, it's not advised, so your test labs for your water samples are not even considering that as an option. So it's just something to think about and have those conversations with your test labs. Maybe you want to go down that route, or like a lot of places, ignorance is bliss, and what we don't doesn't hurt us. When you start doing these things, you start finding out, you realise that there's a lot more risks within the endoscopes, and you start questioning whether the current practices for decontamination are suitable. So, biological biofilm. What is biofilm? Why is it a risk? And what can we do about it? So, biofilm is a thin but robust layer of mucilage adhering to a solid surface and containing a vast community of bacteria and other microorganisms. So this is a little diagram of how our biofilm sort of looks. So you'll have the thin mucilage, or the protective layer, and then inside a vast community of various organisms. So biofilms operate on a cycle. They fully mature after about 96 hours or 92 hours. And this is how the cycle of biofilm goes around. So the first one, you have the initial attachment. This is where the organisms will attach to a surface. And then you have what's called irreversible attachment. This is when the mucilage layer starts to form. And that's the risk with biofilms, the irreversible attachment. It's very, very hard to remove a biofilm. Then we start having the maturation stages, and they progress until we get to stage 5, which is dispersion, where you've got such a large amount of microorganisms under that protective layer, they disperse and pass that through your water system, your endoscopes, your washers. This is an example, and I use this different diagram because it kind of looks, if you imagine, like a cross-section of a channel that you'd see in an endoscope. So imagine we've got the biofilm settling, maturing, the bulk fluid passing over. Imagine that's your disinfectant or even your brushes. It doesn't have an effect on the biofilm until we get to this stage, and then a slug biofilm is released, which then contaminates your water system, the rest other channels in the endoscope, or even your washer. So why is biofilm a risk? As we've already said, TVC samples, biofilm can have, TVC samples, we have a maximum of minus 10 CFUs. Biofilm can contain 100 million CFUs, 100 million organisms released into your system. It's been proven that biofilms are resistant to high-level chemical disinfection. And one of the studies in Sheffield University do a lot of work with water systems, but industrial water systems. But biofilm's obviously relevant in those as well. And one of the things they did is they increased the chlorine content of the water over 20,000 parts per million to try and combat the biofilm. And the only thing that happened was the protective mucilage layer got thicker. So the organisms within biofilms work together to protect themselves and create more of the mucilage layer. And this is why biofilm is such a risk. Brushes may not always be effective, and we'll look at some of the things we can do about that later on. But there's research out there that suggests there's presence of biofilms post pre-clean. And the big risk is, because of the application of endoscopes, it's highly likely or reasonable to assume that any of the organisms that are within the biofilm on an endoscope are going to be pathogenic. The biggest problem we have is that testing for biofilms is not routine, it's not simple, and there's a massive issue with the accuracy. So we can't even detect if we've got a biofilm at the moment, and that's why it's a challenge. But don't take my word for it. Let's have a look at some scientific studies. Now, these are fairly recent, over the last 6-7 years, and I've tried to keep them mainly in the UK and the US, where we know we've got standard practices, and we're doing all the current decontamination processes, parasitic acid, drying cabinets, using them within 3 hours, all of that business. So McCafferty et al., 2018, this was a UK study. They found that lapses in reprocessing result in biofilm formation, endoscope design issues, and endoscope damage contribute to gastrointestinal endoscope-associated infection. Fair assessment? Yeah, everyone agree with that? They said methods of improving endoscope reprocessing, screening for contamination, and evaluating endoscope damage may be vital to preventing future infections and outbreaks. Yeah, I think everybody would agree with that one, okay? So that's just looking into some of the issues with the infections of endoscopes. Alpha and Singh. Michelle Alpha's done a lot of work over the last couple of years looking at various issues with endoscope decontamination, but this study was for the impact of wet storage factors. And they found that there is no doubt that residual moisture stimulates bacterial replication and can lead to biofilm formation. If an endoscope is deemed critical because it enters a sterile body site or breaks a mucosal surface, it should be sterilised. And they recommend bronchoscopes, cystoscopes, ureteroscopes. Anybody sterilising their theaterscopes? Got one person nodding there. Anyone else? Okay, another one, another one. So we've got about 4 people in the room that are sterilising the theaterscopes. What about your duodeninos? No? Are they not considered equally as risky? And actually, the endoscopes have a much greater challenge because of that bridge. It's much harder to clean, and there's a lot more chances of harboring bacteria and biofilms within those type of scopes. They concluded with there is an immediate need to focus attention on the issues of moisture in endoscope channels during storage. The accumulation of biological biofilm in endoscope channels will continue to result in contamination of flexible endoscopes that protects embodied microbes against high-level disinfection. So this is the one that's saying that they're finding that biofilms will be protected, or the bacteria will be protected with a biofilm against high-level disinfections. That's the first issue with the margin of safety with high-level disinfection. Omnibash et al. And I'll just say that the et al. With Omnibash was also Michelle Alpha. She worked on this study as well. And this was flexible gastroenteral endoscopes, process challenges in the current and future perspectives. This was a USA study. So post-processing monitoring studies consistently show high levels of positive cultures remain in endoscopes. So that's full processing. That's pre-clean, high-level disinfection going through approved AERs. Processing deficiency is attributed to the complex design of endoscopes, incomplete cleaning, formation of biofilms, and lack of margin of safety with high-level disinfection. So, again, the complex design. We know we struggle to brush all channels. We know we've got particularly the air-water junction where you can't access it in some endoscopes. I think Pentax, they've got one that you can brush most of the channels, but really the design doesn't allow every surface to be contacted effectively. They went on to say vaporized hydrogen peroxide can sterilize flexible endoscopes with a sterility assurance of 10 to the minus 6. So that's the 6-log reduction we need to achieve sterilization. So that was a study where they're promoting low-temp sterilization for endoscopes. Primo et al. This is my favorite one. And this one was in the UK. This is Cambridge. This is 2022. So we know it's all the current guidance that we're following at the moment. And this was the biofilm accumulation in endoscope channels. And it was the protein of biofilm surfaces of flexible endoscope channels after 30 and 60 days use. So this is the important thing to remember on this study before I show you the findings. Brand new endoscopes put into the system for 30 to 60 days before they were sampled, okay, following full reprocessing, current UK guidance. This is what they found. Extensive biofilm was detected in air, water, and air-water junction channels. 18 out of 28. 18 out of 28 scopes, they found biofilm within them. Brand new scopes. 28 out of 28 showed residual matter. 20 out of 28 showed residual protein was detected in the air-water channels. And bacteria were recovered from 8 out of 21 channels, mostly the air-water channels. You still think that the current processes for decontamination of endoscopes are suitable? That was just a small study. So Lionel Pinu is working, he's part of Eurofins. They've been working on the sampling, and he's currently leading the ISO draft for micro-sampling of endoscopes. It's due to come out hopefully next year. Background contamination rates and studies vary from 0.4 to 49%. Sampling and culturing methods and the definition of indicated organisms vary widely. And this is the issue with sampling for biofilms. Bioburden extraction efficacy varied from 1 to 39% using different culturing methods. So the current sampling that we have for biofilms varies between 1% and 39%. So even if we're getting something, it's potentially only 39% accurate. Again, another risk with biofilms. And it's recommended that a harmonized standard sampling and culturing method for flexible endoscopes is adopted. And that's the work that Mr. Pinu is doing at the moment, and the ISO is in draft. So what can we do? Get the 3-hour rule. I'd get them dried as soon as possible. Why wait 3 hours? Just think of it, if you have 1 CFU remaining post-disinfection, in 3 hours that's going to be 512. In 5 hours it'd be, I don't know, 36,000. It exponentially multiplies. So why would we wait 3 hours? Get the endoscopes dried immediately post-disinfection. I don't know why the endoscope manufacturers, we've been in a more standardized process for 15 years now. We still haven't got an endoscope machine that can completely dry the scope. Why isn't that the focus? Anyway, review the manual cleaning processes. So with the manual cleaning processes, the brushes are the big thing. I like this diagram because it shows part of the issue that we have. Because sometimes you might not have brushes that fully cover the channel. So are the brushes compatible with the device? Are the brushes fit for purpose, even the OEM ones? And I think if anyone who's out in the room, you'll know you've had brushes recommended from the OEMs or the OEM branded brushes that don't quite have that level of resistance. So do they completely cover the entire looming surface? Is there a notable resistance? Can you feel it having an effect? Is it enough? Do we need to do more? So there's a lot of talk at the moment about automated pre-clean devices. We've got the flushing systems out there, but there's new technology coming out now. So some of them use nanoparticles, nanometals, high pressure air and water in combination. And some of them are even claiming biofilm removal. That's a bold claim. So I'm not going to go into them, but we have this one, and this one that could be available soon, or are already. I'm going to talk about them too much because probably some of them will be out there in the room today. The question is, are these the future? If they're claiming biofilm removal, can they actually do it? And should this be what we're looking at to get rid of the last subjective part of the process? We do it in sterile services. We've been doing it in sterile services a long time, that we don't advocate manual processes. We want everything to go through the automated process. But do we already have the answer? Michelle Alpha thought we did. Is this the answer? Is this what we've got? Is this going to be effective? Should we be sterilising all the scopes? Sampling and validation. Ensure that your endoscope lumen samples are routine. I'd make sure that you're doing that, so at least you get a picture of what's going on. Ensure your TVCs have initial indicators for identification, so we know what we're dealing with. Don't worry about the count so much as what the actual organisms are. Consider if using chrome agars is more appropriate for the TVC. That's just my view. Or have a chat with your labs and see what they think. And speak to your labs about a biofilm sampling protocol. What can you do? So what do we do next? Definitely more research into biofilms and the identification methods. Myself and a couple of colleagues at Manchester, we're working on that, and we're doing a study at the moment to try and find a routine test or routine sample method that we can do that gives us an indication of biofilm presence within flexible endoscopes. Standardized processes for accurate and practical biofilm sampling, again, what we're working on. And apply Spalding to different flexible endoscopes. So if it's semi-critical, should we be high-level disinfecting? And if it's critical, should we sterilise? Or should we be doing this for all of them? For a long time, it's on event-related sterility assurance because we don't know if it's sterile, so we have to assume that all the processes and parameters, once performed in the sequence, would render the device sterile. Well, we don't know with endoscopes. I think we've already proved with the studies that are out there, we don't know with endoscopes, and high-level disinfection isn't giving us the level of assurance that we need. So should we consider that we sterilise all endoscopes and treat them the same as we do for sterile surfaces? Thank you very much.